So this is Mrityunjay, MAB 22053, recording problem number 7. The problem says modeling and finite element analysis of a step bar using a suitable software. For this case, since we have used the workbench, so we will use the workbench here to solve this problem. Okay, in workbench we have to draw this step bar. We have to model the step bar. AB is 15 mm with diameter 15 mm and BC with diameter 10 mm. AB having length of 180 mm and BC has a length of 200 mm. We'll first model it. Let's open the ANSYS workbench and start doing it. For that we have to use static structure, since we are doing finite element analysis, and we have to see the engineering data, set the engineering data. Since the data says Young's modulus of a bar is 2 × 10⁵ Newton upon meter mm square, we have to convert it into Newton upon meter square. Then 10⁻⁻6 in denominator. So when we will go to numerator, it will become 2 × 10⁵ plus 6, that is 2 × 10⁻11. Let's see what we have as default engineering data. Static structural steel we have. Okay, the Young's modulus is 2 × 10⁻11. So we don't have to change it. It will remain same. Now we have to go to geometry and draw the geometry first. Let's go to design modeler. Let it get open. Okay, it has opened now. So go to XY plane, look at XY plane. Have to change the unit to millimeter. XY plane, look at XY plane. Unit is already millimeter. Now we have to draw the circle. Sketching. Circle diameter was given as 15 mm. So let's keep it 15. Now we have to extrude this. Extruding it, which one to extrude? Sketch one to extrude, select the sketch one. I have to close this material, close this one to add material. Now we have to set the depth as 180. Now generate this one. Okay, I can see it generated. Let's see, it have generated already, I know, but I have to show it. Okay, this one is generated. Now we have to make the next bar, which was from here, this plane. So we have to shift this axis to here. For that we have to make this as a new plane. Let's make it new plane. Plane 4. We have to keep it. We have to transform this into z axis. We have to set offset z by how much? 180 mm. Now that has come to here. Now I can generate this one and start modeling that. Let's first again get back to XY plane and let's zoom it a bit. Now in this plane we have to draw. So new sketch. This one. Sketching circle. To get the center. This one is the center. To select circle. This is the center. let's give this as diameter as dimension. How much? 10 mm. 10 mm. Okay, extrude this one also. Okay, which one? Extrude 2 now. Sketch 2. Okay, this one I have to extrude. Apply by how much? By 200 mm. Generate this one. Now we got this geometry. Let's fit it. Minimize. Okay, we have to model this one. Geometry is done. Now I have to model. Let this get open. Then start modeling it. Still not open. We have to wait till it gets open. Okay, now we will give the boundary conditions. First we will do the meshing and then give the boundary conditions. Okay, for that we will select the material. So this one is structural steel. Okay, it already is there. This one is also structural steel. Okay, both fine. Now go to mesh. This one mesh. And do the meshing. We have to first generate the mesh, whatever to generate by itself. Okay, it has generated this mesh. We can refine this mesh. Insert and go to refinement. We have to select the geometry. This one to be selected. This one, control. This one, this one, this one. That one. Now rotate it. Select geometry, refinement. Select face selection. This face selection. This face. This face. That face. These two faces are still to be selected, so we will select that also. Face selection. To select this one. Okay. Apply. We got 5 faces. Now we will refine it. Okay, let's go refine it. Generate. So the mesh is being generated. Just wait. 100% mesh generated. Now see the mesh. Okay, I have to fix it. Didn't fit. So this is the mesh created. Now since meshing has been done, okay, now we have to give the boundary conditions. What the boundary condition says, we have to give forces here and here, and we have to fix this. Okay, let's go and do that. go to static structure, go to environment, go fixed. I have to fix this one. Okay, so select single select face. This face we have to fix. Let's apply this as fixed support. This face is now fixed support. Okay, now next, what was the 5 kN force at B? Let's do that. 5 kN force at B. Let's go to force, or we have to rotate it to get that face. Okay, let's rotate it. Okay, here it comes. Go into force. Okay, no need to go again. Just delete it. Go to first one only. This force. Select the geometry. Okay. So single select, face selection. Okay, this face we have to select. Come and apply. If you got applied force, we have to set the force. Now go to component. We have to give the value. We have to look which direction the force will be acting. Okay, this one is in Z direction, so the force will be acting in minus Z direction. So minus Z direction, what was the value? 5000. Let's see. 5000. Okay. Putting that force. Okay. Next force we have to. Next force we have to apply. Again go to force. We have to select the geometry. Again do it directly face selection. This face is selected. We have to apply the force. Apply force here. Surface means we have to put the component of that force. Again it will be in the minus Z direction. Value is 2000. Force is acting. Now I have to check whether all the three conditions is applied. Three boundary conditions applied. Yes. At C, you see, at C 2 kN of force. At B 5 kN of force. Along okay, and B at A is fixed. A is fixed. Okay, fixed support. B is 5000 Newton. 2 is 2000 Newton. Okay, now we'll go and solve this problem. Go to solution. Okay, right click, insert something. We have to calculate. What we have to calculate? We have to calculate nodal displacement at B and C. So let's go and insert deformation, total deformation, directional deformation. At B and C we need, so we can use directional. And total also, let's see total, then again deformation, directional. Okay, B directional. Next directional we have to put now where which one I have selected. This face. Okay, change all voltage to that face. Okay, that is applied. Directional force is applied to that one. Now next directional deformation is applied there. Next directional deformation is at this face now. Selecting this face. Okay, but we haven't selected anything in any faces in total deformation, as total deformation selects entire geometry, all voltage. Okay, now we have selected total deformation, directional deformation this one, directional deformation 1, directional deformation 2. Now go to solution and solve this problem. Let it get solved. Waiting to solving. Till then we can change the units. We need deformation in mm also. Let's put it in mm. Okay. 99% writing result file. Okay, this one get completed, and you can see the results. What are the deformation we got? We have means for this when the both forces will be applied. And this 5 Newton, 2 Newton will be applied there. So, I think we got the solution. Let's see the solutions. total deformation. Okay, so it is saying it is 0. I can rotate that rod. Rotate and zoom to fit. Okay, I can reduce that too. Next, the 0 means minimum deformation is at this end, fixed end, and maximum deformation will be at this end. Okay, it always showing this one is minimum, this one is maximum. We can it will, this point will suffer the maximum deformation, rather than this point. This one will suffer minimum deformation. What was that was the expected result that we got, minimum. This one is maximum. Let's see the animation. Yes, that is the thing. It is suffering maximum deformation, then this, then minimum. Now let's check the directional deformation and this face. So I zoom to fit. Let's rotate it. Okay, this face we have to check the deformation. Okay, deformation. Let's animate it now. This was the deformation at B. Now let's see the deformation at C. To fit. Deformation at C. We can animate this one. This is the deformation at C. Let's see total deformation that we got. This one is a total deformation. Minimum, this is the minimum deformation tabular data we got. Average, this one is the data 6 into 6.121 into 10 to the power minus 2. This one is 3.49 and 1 minus 2. That is what is there written. Now we can, if you want to export this data, we can also do that. Let's do that also. Minimize it and go to Workbench. The result is already prepared. We can go and go to result. We can directly export from there also. From here, total deformation. We will go to export this to a text file. Directional deformation, if you need of point B, you can export, and directional deformation at point C, if you need, you go and click the export. Let's get the directional deformation of point B and C. Export to text file. This is point B. We'll write at point B, so we'll save it at desktop. What we'll name it as B point deformation. B deformation. I will show you what data we got. Save. Next. Let it get saved. Okay, saved. Now we'll go and export at point C also. Export point C. This one's got saved. Now we'll save this one also. Point C deformation at C. Save this one also at desktop. So let's see what were the results we got. Total deformation. Let's come to table. This one is C, B, and this one is C. This is the deformation of B at different nodes. We got the data. We got this one are the data for B deformation. And these are the data for C deformation. Deformation at C. This was the actual model we were saying. We can animate that to see the deformation. It is suffering when the forces are applied. What point B is suffering is seen here, and what point C is suffering can be seen here. Okay. Let's end this program. Minimize this one too. Let's go to Workbench. Okay, that was the problem I got, and that was the result. That was the thing I prepared. That was the answer of this problem. Thank you very much. Thank you so much.